Today, this is a case study on why it will be always discrete. Okay, so that can be explained by using the three methodology. One is at a time only one phase is on and it will be full stop operation, and two phase on with the full stop operation, and third one phase on that followed by two phase on with half step operation, half step rotation. So now we will see the two phase on with the full step operation. Okay, so in the stepper motor, here consists of stator and rotor. The stator is having four poles. Okay, so this is pole 1 and that will be pole 2, and this is pole 3 and this will be pole 4. Okay, and in between the machine there will be a rotating part. The rotating part is made up of permanent magnet. Okay, so it is already having the magnetic property, so no need to give the external power supply. No need to give the external power supply. So the permanent magnet has the two ends. Okay, one end is here and another end is in the opposite side. Okay, so this end is south pole and opposite end is north pole. Okay, and here will be the power supply. The power supply is given only to the stator winding. Only to the stator winding. Now it is two phase on. At a time, two poles are getting energized and the rotor is aligning or rotating in full step operation. Now the power supply is given to pole 1 and pole 2. Initially, it will give the power supply to pole 1 and pole 2. Okay. So now the two poles are act as an electromagnet and the two poles are north pole. This is also north pole and this is also north pole. Okay. So now the center for this rotor is north pole. So this is the south pole. So the south pole that will be attracted by the north pole. Here having the north pole, this north pole is attracting the south pole. But here also having the north pole. So this north pole is attracting the south pole. Now the rotating part, the rotor, it is having the south pole property. Now the rotor is get aligned with either pole 1 and pole 2. But both are north, this one alone south. So unable to move any one side. You can't align with pole 1 or pole 2 because both are getting attracted. And the south pole, this is north pole, it will be attracting like this, but we also attracting. So unable to move any side, so I am staying in the middle of the pole 1 and pole 2. Okay, because I am the south pole, and the south pole that can be attracted by the north, he is also a north, so he also attracting myself. So I will never move any side. So with the help of these two north pole, the south pole will be aligned in the middle of the two poles. Okay, now again the power supply is given to, again the power supply is given to, and next to two poles. Next is two poles. Now it is pole 1 and pole 2. Next to pole 2 and pole 3. So like that it will be gets aligned. Okay, now so initially pole 1 and pole 2 is getting energization, and second step pole 2 and pole 3 is getting aligning, and next step pole 3 pole is getting energization, and next one pole 4 and pole 1 is getting energization. So the rotor will align in between the each pole. In between the each poles. Okay. Now we can start.
Now I am going to power supply pole 1.
Pole 1 and 2. Initially, okay, this is two phase on, and then one phase on and two phase on. Okay, now the power supply is given to both pole 1 and pole 2.
So the south pole will be attracted with the both pole is north.
So he will be at south pole. It will be attracted by the pole 1 as well as pole 2. So unable to move any one side. So it will be in middle of the two poles. Okay. And the second step, pole 2 and pole 3 is getting.
Now I am going to power supply pole 2 and pole 3.
Now the south pole can't move either to the pole 2 or pole 3, so it center between the two.
Now I am going to power supply pole 3 and pole 4.
Now the south pole is attracted with the pole 3 and pole 4, but it can't move either one side, so it is this in the center.
Now I am going to power supply pole 4 and pole 1.
Now the south pole is attracted by the pole 4 and pole 1, but it can't move either one side, so it is rest in the center.
So here, the rotor is not having the continuous rotation. Once the power supply is given to the certain coil, certain pole, once the pole is getting energized, after that only the rotor will rotate. Once the rotor is right in particular pole, again it move another next step. It will wait until the next pole is getting energized. Okay now, so the rotor is always have to wait. The rotor is always have to wait until the next pole is getting energized. Once the pole is energized, so that only the rotor will get moving. So this is called this step angle. You are giving the step angle. There is nothing but and delay time will be given. Okay. So here the step angle, initially the rotor will align it in between the pole 1 and 2, and the second step between the pole 2 and 3 in between. So each step consists of 90 degrees. Each step consists of 90 degrees because now initially it is 45 degrees. That's right. Initially it is it is located in the 45 degree, and second step 90 plus 45, 135 degree. 135 degree. So each and every step the angle of rotation is 90 degree. If the angle of rotation is 90 degree, it is called full step operation. But here at a time two poles are getting energized. At a time two poles are getting energized. So the rotor is always aligned in between the two poles. In between the two poles. Any doubts there? Thank you.